Built Interamericana back in Buenos Aires. I work with Ricardo and Laura. Ricardo, the guy that yesterday showed us that little VM on the Arduino, right? That Ricardo. Well, what I'm here to show you, first of all, I need to start this talk with a little disclaimer. Everything that I'm going to show you is under construction, and that's not a joke. I've been fixing bugs for the last 48 hours just to get something kind of working in order to show it here. And I honestly assume that it's going to fail. The best thing that can happen is that, at least if it fails, I hope it fails in the worst spectacular way, so we have a laugh, right? Good. I've been working on this. There's actually a longer story behind it, but I've been working on this project particularly for the last, I don't know, 3 months or something like that, so it's all fairly new. But before I go into the specific topic, there are two things that I want to remark about something that is in the computer systems that we use and that we build. One of the things that I want to remark is something that we've been hearing for the last 2 days at least. That's the idea of the smalltalk image, the state of our application, right? We have the live objects. We have a really nice talk yesterday about it. I'm going to go into details in the next slide. But the idea is we have everything that our program is and everything that our program can do defined in our program itself, right? That's the state of our application. And another thing I want to just to mention, to keep in mind, is that besides the fact of what we can do, there's the act of doing it, right? There's the execution. There's the how we're processing what we need to do, right? Two things. Keep it in mind because we are going to talk about it in a few minutes. Actually, when Ralph Johnson, who talked yesterday, I don't know if anyone was here, talked about the smalltalk image, he made me a huge favor because this is something I needed to talk about. So now I can just talk about his talk and everything is fine. The first thing he said that I really want to remember, I want to keep in mind is the persistence becomes trivial, right? Because we have the live objects, we have what our application is, and that same model, that same thing is persisted almost automatically. So suddenly we don't really need an external database like an SQL server. We might need it for a specific application because we have an enormous data amount, but it's not a requirement for us to do something. the second big thing that's kind of a smalltalk characteristic is that the behavior is defined by the data, right? If we change a method, that method is part of our data, we can change how our system will behave. This is a keystone of how Smalltalk is so flexible, how Smalltalk can let us grow and change it over itself. And there are two things that he said that are the things that I'm here or that I want to solve. He said, we have one object space. That's a really wonderful thing. Right? Everything is alive, everything is together, everything can talk with everything. Unless we know that the real world doesn't work like that, because we have different computers, we have different devices, and the reality often doesn't agree with what we want it to do. The second thing he said is Smalltalk image is a single user thing. I have my Smalltalk image on this machine, and it's mine, and mine alone. Even in the nice demo that Bert did with Squid.js, it was his image in his browser, in his computer at that moment of time. He could save it, he could export it, but it was only one person using it at any time, right? One of the things that really caught my attention is the last advice he gave, that he said the Smalltalk image gives an unrealistic unrealistic view of how a distributed system works. Because that's actually an advice that I didn't get in time, because that's what I try to do. I'm going to go into it in a few slides. The first thing I need to talk about is Google Docs. Everyone here has used Google Docs, right? Everyone knows what it is. Well, actually Google Docs started before Google. I think it was 2005, with 3 programmers that were trying to test what they could do with Ajax, with asynchronous call in JavaScript. And they built a small text editor that worked kind of like the Google Docs we know. The idea is powerful, right? We can build a web-based document editor, but the important thing is not that's in the cloud, that it saves itself, that we can go back and go forth. But the important thing of Google Docs is the other part, the part that we can use it to collaborate, right? We can edit the same document at the same time from, at least in theory, anywhere in the world, as long as we have an internet connection, right? Well, the beauty of it is that in 2003, Google actually released an API to work over Google Drive files, and it used the same synchronization engine that works in Google Docs. So that API at the time was called Google Realtime. This was like 3 years ago, and in that time it has grown, it has gotten better, it has gotten faster. But there are some interesting things, and I'm going as fast as I can with these slides just because I want to go to the showing how it works part. It's more interesting. The thing is, what they did is they give you an API. You include it in your JavaScript as a resource from their server, and with that API, what you could do is you load a Google Drive file that's going to work as your storage, and you could synchronize a graph of objects of some specific types, right? They have an implementation that was the collaborative string that has all the specific implementation requires in order for several users to edit different parts of the string at the same time and handle the collisions, for example. The thing is, it not only synchronizes things in a graph, changes in a graph, but it also has an event model built on top. So we can build reactive code to work when anything changes in our model. And there are several things that are built on top of this. I don't know if you have seen, like, I don't know, a graphics editor that's collaborative, an object thing like Visio of Office, but in the web. They are all built around the idea of using this. If you can model your thing, your domain of problem as a graph, then you can use this as a synchronization engine. So I'm a programmer, right? I like programming, and I guess that's why I'm here. And the domain of knowledge that I know, that I use, is programming. And in programming languages, especially in object-oriented ones, we know that we can think of the memory of a computer like a graph of objects, a graph of live objects. We know the physical memory is a big array of bytes, but the conceptual memory of an object-oriented program is just a graph, right? So when I saw this, I say, why could not we build an object-oriented programming environment similar to a smalltalk image that was built on top of these synchronizable objects, that was built on top of Google Drive? So if anyone has to pay for huge data centers, it's Google Drive and Google and not me. That's one of the good things, I guess. But what is nice, what I'm doing, could be described as this. I have 3 parts to build. First of all, I have a core in JavaScript that's kind of like Elliot's VM of Smalltalk, or what Bert showed us when he loaded a quick virtual image into the browser. They build virtual machines. That small JavaScript code, and nowhere near what Bert has done, which he showed us yesterday. They were like, I don't know, 20,000 lines of codes of files. So the idea is simple. I want to build something small that compiles into JavaScript, because I want to use the execution power of V8, and I want to use the synchronization engine of Google Drive, but the objects that are provided to me by my virtual machine are inherently synchronized. And now I know that I'm going over and over with this synchronization idea, but we're going to see it work. Over this layer, that's the base library that I need to build something, I want to build a core language, a small subset of what I want to do. And this is what I'm here to show you, right? The first thing I need to tell you, before actually showing it, is that this is not Smalltalk. Hola, right? This is not exactly Smalltalk, and I don't need it to be. The idea of this language is an internal language that's powerful enough for me to do what I need, but is flexible enough for me to do things that the real language should not allow, right? I don't want a high-level modeling if I need to talk to JavaScript. This layer over here, is what I'm going to use as base to build another language. What that's going to be on top, right? Here could be Smalltalk, why not? Or could be anything else. I have no idea what should go up there because there are certain peculiarities of what I'm building that maybe Smalltalk, as it is today, is not ready to handle, or maybe it is. But the idea is simple. I have a JavaScript code with a little parser and a compiler that parses a semi-Smalltalk into collaborative objects, right? So what we are going to see, right? Here I have a Chrome, right? I'm going to enter in a web page, and what we're going to be looking at is a small file browser that is looking into a Google Drive folder in one of mine. Okay, I have to stop PowerPoint, it seems. Right, a little file browser. So we have some data like the name of our files, the size, who created it, and some actions we can do. That's not the important thing, right? It's just a file browser. I'm going to create a new file. It's going to take some time, it's going to do some stuff, and then I'm going to open that file. This is all I have today, right? I only have a REPL, a small console where I can execute code. What we are seeing on the bottom of the screen is the first tool that I have to show what the model is, what the objects in the memory are. I don't know if you can read it, it doesn't say much. The only important information that's there is what document is open, right? But if we look at what's inside of it, there are two interesting things. First of all, since this is built on top of Google Drive, I'm using Google Authentication, so I know who has this file open, who is connected to this image, and there are two people. Mainly because the first is my code up there, and the second is the inspector down here. Both of those users are my account, but only one is saying this is me. I can identify specifically which user is connected to my Smalltalk image, and if that user is me. The other thing that we have at the bottom is our execution context, similar to the active context that Bershot showed us yesterday, with just a subset of the things I've been building. So I have object, string, list, number. There are some peculiarities to the internal representation of some of this object that I would like to see if we get into time. Then we have a small console with 3 buttons. I can pass the code, I can compile it to JavaScript, and I can evaluate it. So, if I do this, 3 plus 4, I get a result, 7. I'm going to close this for now. Right? That's not really interesting. The interesting part is that if I say something like, let's have a variable named A, that's the result of executing 3 plus 4. If I ask for the value of A, I get 7, right? That's what we expect. I'm going to do this, and on the, well, if I don't misclick it, on the left of the screen, we have another window open. It's I don't know if you can see it, but it's in incognito mode. It has another account connected to it. I'm going to refresh this page because I created a new image. And I'm going to open the same image, right? The idea is simple. I execute a code in one of these two windows, and both of them see the same execution. The idea is we have one theoretically infinite large image, and we are only viewing, we are accessing the same objects. So, if what I told you is true, and I ask the value of A on the other window, I get a 7, right? That window got the state of our program from the Google Drive. But that's just numbers, right? Let's do something more fun. When I said this was not a complete small talk, it was a subset, it was not a joke. I don't have classes here, and I don't need them. All I need to do is give me the tools to build classes on top of it, right? So I'm going to build a small class, or the equivalent of a class to me. Let's say I have a variable named counter. One of the things I forgot to mention is everything here has late name binding. So if I can change anything, like in the Newspeak talk that Shihila gave yesterday. I have a variable named counter over here. It's really confusing because in my side I see it on my right. But let's say counter equals a new object. Object. I want you to pay attention because over here is going to appear counter somewhere. If you look at this, counter is at the bottom. Because when I did a modification of my object graph in one of my windows, that modification impacted into Google, and Google replicated that modification in every other window that had this open. Let's say a class has several responsibilities, right? It has to define what an object can do. That's one of the main reasons we have classes. But what I did is just an instance. It doesn't know how to build objects, so it can work as a class. So I'm going to do something that's similar to self. I have a prototype kind of thing going here. I'm going to take counter, and I'm going to add it a method. I'm going to say, okay, now you can answer this message. And I'm going to say, okay, you are going to build an instance. So I'm going to ask you to answer to the message new. The first thing that the execution of new should give me is an instance. So I'm going to build one. I'm going to say I have a local variable named instance, or even better, named self. And the last thing I'm going to do is return self. The pseudo smalltalk I'm building returns the last statement result. So doing that, the last thing that's going to come back to me is the value of self. Self is a variable in this case, pointing to nothing because I didn't do anything with it. But I can do this. Self equals an object basic new. I'm going to move it a little bit lower. Right. So if I want a class to be able to count things, I'm probably going to need another variable to hold that value, right? An integral kind of value. So I'm going to give it another 3, and I'm going to build some methods to it. I'm going to add it a way to get that value, a way to modify it. I get a setter. So self, that's an object that can answer the message add method, because object actually built that into any execution of basic new. The first thing that I want this instance to answer is the value of the count right now. So I'm going to say count. Count has to return the current value. I built this local variable here, so I'm saying you're going to return val. I haven't done anything with it yet, but I could, for example, set an initial value here. Val equals 0. I'm going to add a second method that's going to increase the value of val by 1. I'm going to say, okay, let's bump the counter. Let's add 1 to the counter. Equals val plus 1. And I think we can start working with this. When I execute this code, I'm replacing I'm adding behavior to the instance that's pointed by the counter variable I have over there, right? Or at least that's what I think I'm doing. Over here, if we can inspect what happened in the other window, suddenly there is this new at the bottom that wasn't there before, because I added that capability to this object. But if this is a class, then I can get an instance of this class. And if I didn't break anything, I could do something like this. Counter new. And I get an object. That's all it says. But I could do this and ask for the current count. I could do this and bump the count, and I get 1. Going over to the screen, I get the current count, and start playing. Okay, I kind of printed the screen. Nobody saw that. And I'm executing code in one window, and I'm seeing the results in the other. And here's the thing. When in the talk of Ralph Johnson, he said, look, usually making the distributed system transparent doesn't work because of the round trip. He was saying the truth. When I do this, when I send a message to C from that window over there, it doesn't travel all the way to my memory over here, gets processed, and the result goes back. Every execution is local to every window. I could get a different machine. In fact, Ricardo over there, the one in the corner, has the capability of modifying this, because he has access to my Google Drive file. What happened is, I'm replicating the state modifications, right? When I say C bump, the internal value of a variable inside that instance is added by 1, right? I change it 1 value. That is the change that I'm synchronizing. If I do something like this and say 3 plus 7, nothing gets synchronized. There's not network traffic because no impact has been made on my object graph, right? Good. There are some optimizations that I had to do in order to make it work that make me handle different numbers, strings, collections, and objects. For example, if I wanted to do something like this, factorial, I get a do not understand, right? Why? Simple, because I didn't build it. I didn't give number the capability to respond to this. But I could build on top of my language the implementation of factorial. Actually, I had it over here just in case I don't do it right. I'm gonna copy it. Look, it's easy. Cell number, that's a dynamic name, that's gonna give me an object. To that object, I'm gonna say, add a method named factorial, and it's going to say, if my value is 0, I'm going to return 1, otherwise I'm going to return the factorial of me minus 1 plus myself. It's the classic recursive implementation of factorial. If I do this and then go back to 3 factorial, I get the 6 that I should have gotten in the first place. But, as I was saying, I can do it over here as well, because I'm seeing the same Smalltalk image, right? Good. There are other things that I have. For example, I can build an array. Actually, I don't have arrays. They behave like lists. I can add and remove items. So, let's say this is a literal array, and it's empty. And I could insert data into it. For example, what I do is I'm going to copy this little method that's really similar to what the factorial does. If you see, I'm going to add a method named times do, and it's going to receive a block of code. If the value of the current number is 0, then it's going to do nothing, because nothing. But if the value is not 0, I have an if false here, then I'm going to execute the block, execute self -1, and do a times do again. So it's a recursive execution to get a times do. I want to execute 10 times, right? What I can do now is say something like, okay, 10 times do. And I'm going to give it a block of code. For example, I could say, well, first of all, I'm getting the current number. I could use it. But also, I could use it because if you look at here, when I say a block, value with arguments, I'm passing myself by passing the number. What I could do is say something, for example, like C, bam. The current count of C was 3. If I execute this, the current count of C was 4 because I did something wrong, for example. Oh, it was executing actually. I asked in one computer while the other was executing. So I saw an intermediate step of that process, right? If I ask now, it's 13 because it actually added those numbers. But what I was going to do was say, I have this array. I could do 10 times do, getting the number, and say array parse number. And our array is filled with numbers, right? What I'm going to show you is I have those same collection iterations. What? Oh, okay. I'm running out of time. So I can do something like this. Let's say I got array collect. I get each item times 2, and I get a multiplier. Or I could say, what if I get each, the string I think it was, I don't remember. It's easy to test. Yes, those were strings. Right? What happened here is, for each item, I converted it to a string, then I appended it, hello world, at the end. So I get an array of strings. I could take, for example, a string, ask it, list I think it was, to become a list of characters. Actually, there are not characters, there are more strings. All that time, the last thing I want to show you is that, as Bill showed you yesterday, that he has his Squeak.js running on his iPad. All this time, I could access all of this from my phone. Because the internal implementation of this library actually uses several different technologies, that some of them are compatible with mobile phones. So I could go in here, I don't know if you reach to see it, and I don't know if the internet is working, but here I have the small new button that's on the browser, and it's not loading just to make me lose time. But anyone who wants to see it, the conference is going to be for this another day, so I have my cell phone here, anyone can see it work. The same thing that happened between those two windows happens with my cell phone at the computer. And some things arises from this. I could, for example, distribute automatically computing. So the act of executing code becomes distributed. I could say, okay, I need to go through a huge array, for example, and do an operation. I could say the first 1,000 operations are running my computer, the second 1,000 are running my cell phone, and I could take advantage of any processor connected to this, because what I'm synchronizing is the conclusion of the execution. Of course, like everything in the world, nothing is perfect, it has some limitations, yes, but there are some things that I want to do with it. First of all, we here have an environment that has a characteristic that's not normal, right? I can get modifications, mutations of my state that are not coming from me, they're coming from anywhere, and I cannot predict them. So what was talking about of the event listeners and the observers, that's something that needs to be built into the language, right? Because everything can mutate at any time. There are some issues with the garbage collecting, there are several things that I need to go into, but there are limitations that I want to address. First of all, first of all, I want to thank you, and I guess that's it. Okay, the idea of an infinite Smalltalk image is not possible, but we can simulate something close enough for us to build large projects that work as a huge Smalltalk image working in several devices. For example, I could use my counter application to count everyone that goes into the room by tapping my cell phone in the door. And it will be the same Smalltalk image. I just program it once. And I program it as it's running locally. And actually it is, right? But there are several things that could go wrong. But I think that's about it. So thank you.
So that you're the next. Okay. Next. So while they're changing, if somebody wants to ask a question, I don't know what.